One of the best ways to find publicly available geospatial data is to access online open source databases. There are hundreds of these types of databases that are specific to geospatial data. Local and federal governments often have open data resources that you can find by searching the name of the city, country, municipality, plus open geospatial data in any web browser. When you find these databases, you'll often find a variety of data file types, including CSVs and shapefiles. Depending on the type of map that you want to create, some data forms might be more helpful than others. For Switzerland, I'm going to use a website called NVDAT to download some free publicly available environmental geospatial data. Between this website and opendata.swiss, there's a lot of data to work with, especially for Switzerland. So I highly encourage you to download some other data and explore how you can map it after finishing this tutorial. Okay, so going back into our script here, the first thing that I'm going to do is load a couple of new packages. So the first will be a package called read Excel, and that will just allow me to load in some Excel data nicely. I'm also going to load our geo boundaries package, which will allow me to get the administrative boundaries for Switzerland's cantons. So that's just the name for the provinces or states or kind of sub areas of Switzerland. They're called cantons. Okay, so from the data that I downloaded that is available alongside this tutorial from NVDAT, this data is highlighting different locations of avalanches in Switzerland. As many of you probably know, there's a lot of mountains and snow in Switzerland, so with that comes avalanches. So I'm just going to start by loading in these packages and loading the avalanche data set, which I'm just going to save as an object called avalanche, and then I'll preview it using the head function. From this data set, I can see an ID for the avalanche, the date that it occurred, the hydrological year, the canton, the coordinates in latitude and longitude, and some more information about the elevation, the slope aspect, the danger ratings, as well as number of people who died, number of people who were buried, and any sort of activity that may have caused the avalanche. So a lot of information contained in this data set. I'm also going to use the RGeoBoundaries package to get the administrative boundaries for each of these cantons. So I'm going to use the GeoBoundaries function from the RGeoBoundaries package, and I want to specify that I want the boundaries for Switzerland, and then I want my administrative level, or ADM underscore LVL, to be equal to ADM1. So that's basically saying, don't give me just the boundaries for Switzerland as a country, give me the next most specific level, which are the cantons. So I'm going to save that as an object called canton, and then just show that information from that object so I can see what I'm working with. So when I look at what the canton object looks like, I can see that I have a simple feature collection of a geometry type multi-polygon. And I see some groups, the names of each of these cantons, shape IDs, and the geometry column. So that geometry variable is going to be what allows us to actually create the map of these cantons. Now, in order to eventually match our avalanche data with this canton data, we need to change the canton codes in the avalanche data frame to the full name seen in the canton data frame. So I'm just going to create a new variable called shape name within the avalanche data set and just save a bunch of NAs in there. So when I do that, I'll just take a look at my avalanche data set. And if I scroll all the way to the right, I'll see I now have a new variable called shape name. Now what I want to do is in that new shape name variable, when each of the canton IDs, which are just stored right now as two-letter identifiers, when those different letters are equal to certain combinations, I want to store the full name of that canton in my new shape name variable. So I just looked up exactly what these two-letter codes stood for each of these cantons, and I make sure that my spelling and capitalization match the way that they're spelled in the canton object. So not the prettiest way to do this, but it is very effective. So I'm just going to highlight all of these different all of these different canton names and replace them in the shape name variable. So now when I look at my avalanche data set again, over in my shape name column, I should see that all of the avalanches that have a corresponding name in our canton data set also have the correct shape name in the avalanche data set. Now, like I said, we have some information on avalanches that happen in parts of Italy and France as well, because these are happening kind of across the Alps mountain range. So I want to only include cantons that are present in my avalanche data and remove all of those that are just equal to NAs right now, because those are not ones that are also present in my canton data. So I'm going to use the subset command and just make sure that I remove any instance of NAs in that new shape name variable. All right, and so then the final thing that I want to do is take my avalanche data and calculate the number of avalanches per canton per year. So I'm going to use a short piped statement and save a new data set called avalanche summary years. And I'm going to use my avalanche data set and group by the shape name. So that will be the full canton name that we just defined and the hydrological year. And I want to just do an avalanche count summary variable that just counts how many avalanches occurred during that year. So I'll run that section of code. And if I take a look at the avalanche summary, I can see that for each hydrological year and for each canton, I have a count of the number of avalanches that occurred in that canton in that year. Then I'm also going to calculate the proportion of avalanches that happened in any given canton across all these years. I'm going to calculate the proportion of all the avalanches that occurred in a given canton. So this is now more proportional to areas that may get a lot of avalanches versus areas that get just very few. We'll be able to actually directly compare them. So I'm going to do a little bit more of a complicated pipe statement and take my same avalanche data set and now only group by the canton name, calculate a same avalanche count. So this is just now the total number of avalanches that happen across all the years. And then I'm going to calculate the total number of avalanches and divide the avalanche count by the total number of avalanches to get a proportion of avalanches that happen in each given canton. So if I execute that line of code and look at the data, I can see that I now have all of my canton names, the count of avalanches that occurred in each canton, the total number of avalanches, which will be the same for all cantons, and then the proportion of avalanches that happen in that canton. Okay, and then what I'll do is merge this new avalanche summary total data set that I've just created with the proportion of avalanches. I'm going to merge that with my canton data by the shape name. So what I will wind up with is a data set that has my geometry from the administrative boundaries of the canton, and then I'll have a proportion of avalanches that happen in that canton relative to all the other cantons. Okay, so I have my final avalanche summary data set. So I'll go and look at that, and you can see that that's exactly what I have now. So I have all the information for the canton names and the proportion of avalanches that happen in that canton. And then if I scroll all the way to the right, I can see that I also have the geometry for that canton. So I'll be able to use this data set to not only create the canton boundaries, but also add some descriptive information using color about the number or proportion of avalanches that happen within that canton. So to do that, what I'll do is build a ggplot, and I'll first add a geom SF using the canton data. And I'll just fill it with white and put an outline of a kind of dark, um, almost black color, just to show the administrative boundaries. Then I'll add another geom SF, this time using the geometry variable from my new combined avalanche summary data set. And I'm going to fill each of the polygons that are plotted based on the proportion of avalanches that occurred in that canton. In order to tell ggplot which colors to use, I'm going to use scale fill gradient to show that lower proportions of avalanches are this kind of beige color, and higher proportions of avalanches are more of an orange color. And then, as always, as we're learning with all of these types of plots, with these SF geomes, I need to add in coord SF, and I'll just add in theme void to remove any sort of other plot features. So I'll go ahead and plot that, and I can see that for some of the cantons kind of in northern Switzerland, where, spoiler alert, there's not many mountains in that part of Switzerland, we have no data for avalanches. So no avalanches have occurred in those regions in Switzerland. But then we can see that we have two pretty dark red cantons kind of in the southern parts of Switzerland with some varying levels of beige and dusky pink colors as the different proportions are plotted.